So let's start. The first problem is related to circular motion, which I'm not sure because someone just told me that you have not studied the circular motion yet. But you have kind of three situations, and the question asks like if a ball is thrown into the tube, which path it will take when it exits the other side. So you have three paths, A, B, and C, and you're supposed to tell which path it will take. So it's circular, like a circular tube, somewhat like this. And you throw a ball from this side into the tube, and from this point it exits out. So you have three paths. The first path is this one. This is path C. Then path B is this, and path A is this, which apparently going towards the point from where the ball enters the tube. So this is like a fundamental characteristics of circular motion since you have not studied it yet. So I'm gonna give you the answer. The path that the ball takes is C, this one. So it's a simple case scenario. The ball at all times, it wanna move tangent to the point at which it is at the moment. For example, if you wanna see that if tube ends at this point and this is the ball at this point, then which way it will exit, it will take a straight line path. So at any point during its motion, it always takes a straight line path. If you ask if the ball exits from this point, then it will take this path. So it always takes a straight line path wherever it exits. Okay, so these will be the possible paths at different points in the tube. Why it moves in the tube then? Because it's constrained by the tube. It cannot go out of the walls of the tube. It's constrained by the walls, and that's why it moves inside the tube. But if it has to exit, as it will at this point, then immediately after it exits, it will take a straight line path, and straight line path is C. So if you consider these different points, like for example, this point, it will take a straight line path. At this point, it will exit straight. At this point, it will exit straight in this direction. Okay, so that's like that's like a general characteristics of a circular motion. It does not depend on whether you consider a tube in which the ball is moving, or you just attach the ball to a string and try to move it in a circle. If you just take a tennis ball and tie it with a string and then make it move in a circle, if you leave the string from your hand, it will move at a tangent path. If the ball is at this point and then you leave the string, it will move straight in this way. If you leave at this point, it will move in this direction. It always goes tangent to the point where it leaves the string or leaves the tube or whatever the force is which is constraining it to move in a circular path. Anyway, that's the thing which probably you will see in your future classes. Question 2 is about the dynamics of vectors or the vector quantities. And I guess we had studied this kind of thing in our last class, or maybe the class before that. Like you are given, in these three diagrams, you are given two forces. And the forces are on a gridded scale in different directions. So that gridded scale is actually, it corresponds to the coordinate axis that we choose. So we have X and Y coordinate system. This one is X, this one is Y, and then we have forces directed along different directions. Let me use different color for forces. So the first force, F1, for the first problem, it's directed in this direction such that this is F1 vector, such that its X component is 2. So this value is 2. You can see in the diagrams given in this questionnaire, and the Y value is 1. So this one is 1. Each the scale on the grid, each box, each small box corresponds to 1 unit. And the second force is in this direction, such that this is F2, such that the value on the x-axis is 2 and the value on the y-axis is 2. It is something to note that since the x value is along the negative x-axis, this you can see on this grid sheet that is in this in these questions, this is -2, because all the values when we move towards positive x-axis they are positive, and when we move towards negative x-axis they are negative. Since these are vector quantities, these are forces, that's why we have to take care of positive and negative sign. If they were distances, then we don't care about them. The distance from between these 2 points is still a number. It will be the difference of values of these points, which will be 2 minus -2, which gives you +4. That's distance, that's a scalar quantity. But since these are vector quantities, so we have to take care of direction, and these negative signs, they correspond to direction. Okay, so the general rule, general method to find, so we have been asked to find the missing force such that the values of acceleration are given. So the values of acceleration are the following: AX equals 2 meters per second square and AY equals 0 meters per second square. Yes, 0 meters per second square. And the system is in equilibrium under the action of 3 forces. The third force is unknown, which we are going to find. Okay, so we know the general rule, and this is a big hint that they have given us the accelerations along x-axis and y-axis separately. This immediately signals us towards that we are going to use the components of the forces separately. That's the Newton's second law in component form, which tells you that sum of all the forces acting along x-axis, this is equals to mass times acceleration, net acceleration along x-axis, and then similarly sum of all the forces acting along y-axis equals to mass of the object on which the forces are acting times the net acceleration along the y direction. So we have been given the acceleration, we have been given the 2 forces, their components in fact, and the third force is missing, so we can simply consider that third force in terms of component and use this equation. The first equation, it will become, since we have 3 forces, so this become x component of the first force plus x component of the second force plus the third force, unknown force, that we are going to find its x component. So let's call the third force as F3, and its x component will be F3x. This is what we are going to find, and they will be equal to the mass of the object on which these forces are acting times acceleration AX, which is 2 meters per second square. Okay, so F1x, that's +2. So F1x is +2. Okay, I'm gonna use this +2. F2x is -2 plus F3x. This is what we are going to find, equals 2m, and the units are meters per second square. So 2 minus 2, this gives us 0, and so F3x we get immediately, this is 2m times meters per second square. Okay. Similarly, we can use this second formula for the y-directed forces. Acceleration is 0. I'm going to use it here. So similarly, this will be F1y plus F2y plus F3y, the y component of the third force, which we are going to find. And since acceleration is 0, so we will have right hand side m times 0 meters per second square, and 0 will multiply with this m and gives us 0. And so F1y is 1 plus F2y, it's this value, the y component's value of f2, which is plus 2, plus f3y, which we are going to find equals 0. And so this gives us f3y equals minus 3. Some units, it should have some units. Okay. And the mass of the object is 1 kilogram. I did not read it first, but it makes sense because I need mass in order to solve the problem. And if I put m equals 1 and it's 1 kilogram, so I'm gonna substitute it with 1 kilogram. 2 multiplied by 1 will give me 1, and there will be kilograms multiplied with it. I'm keeping the units explicit just to give you an idea that it gives me the right units for the force. The force has units Newton, which are equal to kilograms times meters per second square. And this is exactly what I'm getting on the right hand side, which means that I'm calculating the right quantity, which is force. So I have both components of unknown force, which we have called F3. We have the x component equals 2 and the y component equals 3 minus 3. So the magnitude, formula for magnitude of this third unknown force is F3x squared plus F3y squared whole square. So I can calculate the magnitude. So x component is 2, 2 square is 4, plus minus 3 square, which is 9, and so I immediately get 13 square root. So this is the magnitude of third force, okay, square root of 13. We also need its direction because it's a vector quantity, and in order to completely represent a vector quantity, you need two pieces of information, magnitude, which we have just calculated, and direction, which you can calculate by using, of course, again, these two components. And the formula for that, like in which direction this will be pointing, is tangent inverse f3y divided by f3x. The third y component of this f3 force divided by x component of this f3 force. And if you substitute the values now, so we get tangent inverse f3y was minus 3 and f3x was plus 2, which is minus 1.5, and this turns out to be I assume 56.3 degrees negative sign. Okay, now this is what you get if you use your calculators, which I assume you are going to do. Okay, so minus 53 degrees. So to the convention for measuring the angle, the general convention is the positive angle you measure counterclockwise. For example, if you take this F1 force, it makes some angle with positive x-axis, and that's how you measure. So this arrow represents the direction. This is the positive angle. Okay, what about negative angle? If you move in the opposite direction to this direction of angle, you go to the negative angle. So you are looking for negative 56.3 degrees. So negative would be in this region in the downward direction. And so the third force will be somewhere in this direction. This is F3, and this angle measured in this direction is minus 56.3 degrees. That's with positive x-axis, but with negative sign. This is very important, how you answer your angle. This is negative 53. If you generally go with the convention of measuring angle in the positive direction, like if you wanna give the angle for the force F3 in the moving towards the positive angle, then you have to calculate all this angle. How can you do that? The angle for this entire circle is 360 degrees. So what you do is, let's say this angle clockwise, counterclockwise direction, let me call this phi. So in that case, phi angle would be 360 minus 56.3, which will turn out to be 303.7 degrees. So this is with positive x-axis. Why I'm telling you this? Because on your exam I'm not sure which kind of convention they are going to use. So you have to look for both. This is easier one. Because you just plug in the values in your calculator and it gives you the answer. That's it. But then you have to make sense of it in regard to the problem you are trying to solve. Like, what does this angle mean? The general convention that we use and the author use in the books is that they measure the angle with the positive x-axis. With positive x-axis moving in the counterclockwise direction. And so in that case, you might find this answer in the book for the angle 303.7 degrees. But your calculator will be giving you minus 56.3 degrees. That minus sign with the angle is a big hint that what you are measuring, what calculator is telling you is this angle. This angle is correct, it's not wrong. What I'm just trying to say, maybe in your exam it's not 56.3 degrees, maybe it's 303.7 degrees. So be careful about these things. Don't be confused if your calculator tells you this angle, but it's not even in the options in your exam or in your book. Okay, that means probably they are using this angle. These both angles, by the way, give you the same value. If you plug in tan 303 degree and tan minus 56 degrees, both gives you the same values, precise same values, no difference between them. The only difference is like how you measure them. That is the general procedure for all these three problems. So I'm gonna pick one more so that we can move to the next two questions. They are also important regarding free body diagrams. Okay, which one should I pick? Do you have any choice for the next two diagrams? So I'm gonna solve one more from these. Should I go with my pick? Okay. Let's go with the third one. It doesn't have any information. It just says the object moves with a constant velocity, which of course tells us that net acceleration is 0, but let's go with this one. So we have a coordinate system. Again, that's the basic thing which is always there regardless of whether it's given in the problem explicitly or not. And we have two forces. F1 is in this direction, so this is F1, and then we have F2 in this direction. We have component values. The y value of F2 is +2. Its x value is +1. This value is +1. Then for F1 we have y value -2 and the x value +1. So this is the same. Okay, my diagram is a little off, but yeah, please. You have a question?
But are you doing number 2 or number 3?
This is third. Okay, I needed to do 3. Sorry. Thank you for pointing this out. Yeah. Okay, that is the second one. Yeah, let me do the third one. Okay, the third one is F1 is in this direction, and its x value is 2, y value is 1. Then we have F2 in this direction. Both are 2. So x value is -2, y value is +2. Okay, so these are forces, and there is a third force missing which we are going to find, such that the object moves with constant velocity. Okay, if the object is at rest or it moves with constant velocity, in both cases acceleration is 0. And we have not been told that whether the acceleration is the x component of acceleration or the y component of acceleration. Okay, they say that the object moves with constant velocity, which means that the net acceleration is 0. But again, these equations tell us that if net acceleration is 0, it can be 0 under only one condition, and that condition is if its individual components are 0. So with one word that moves with a constant velocity, we have been told that x component is 0 of acceleration and y component is also 0. And so again we can use this same procedure. This equation gives us this. So summation fx equals m times ax. This gives us f1x plus f1y, f1x plus f2x plus f3x equals 0 because the acceleration is 0, ax. And f1x, this force, it's 2 plus f2x, it's minus 2, and plus f3x, this is what we are going to calculate, equals 0, and this immediately gives us f3x equals 0. So f3x is 0. Now we look for f3y equals m times ay. This will be f1y plus f2y plus f3y equals 0 because acceleration along y-axis is 0. f1y is 1 plus f2y is plus 2 plus f3y is the quantity that we need, and so from here we get, am I missing something? Just 2 plus 2. Okay, so f3y is minus 3. Just to make sure that I don't remember finding this thing. f1y is plus 1 and f2y is plus 2. Okay, it is what it is. So f3y is minus 3. So we can calculate first the magnitude of this third force. And since f3x is 0, f3y is 0, the magnitude will be f3, it will be f3x squared plus f3y squared whole square root, and this will give us 3. So the magnitude of this third force is F3. If it's indeed a force, the unit should be Newton. If it's any other quantity, you can just write units because it should have some units. So the magnitude is 3 Newton. Now we need to find the direction, and the rule for direction is this formula. This will be theta equals tangent inverse y component, which is minus 3, divided by x component is 0, and this, if you calculate, is something, I believe, which gives you 90 degrees. Okay, and so the third force will be along this direction. Magnitude minus 3 and the angle 90 degrees. Can someone tell me which 90 is it? Is it positive 90 or negative 90? This 90? Okay. Or if you measure from this side, this is gonna be 270 degrees. Can someone give me any other argument that it should be in this direction? Just from the statement of the problem. Problem says the system moves with a constant velocity, 0 acceleration. You see, both of these forces are like positive, directed in the first 2 quadrants. So their net force should be in upward direction. And if you want net force to be 0, the third force should definitely be in the downward direction. For example, if you take plus 90, let's say if you try to make this angle 90, you immediately see that x components may cancel, but the y component of this force is in upward direction, of this third force is in upward direction, this one is in upward direction, and y components will never cancel each other. And if y components do not cancel each other, there should be a net acceleration, net y acceleration, but our y acceleration is 0. So it should definitely be in the downward direction. The other hint is that you see this is minus 3. This is just like this minus 3. Negative y component tells you that your final vector should be pointed in this lower region, lower 2 quadrants, and in this case it's 90. Okay, this is the general procedure. I just want you to double check it, and this is correct, but I'm not sure. When I was solving last night, probably I remember I get -1. Doesn't really matter, gives everything same way, but I don't know why did I get -1, or maybe I should double check my solution. Okay, this is 5. Yeah, that's correct. Okay, so let's move to the next two parts, which are regarding free body diagrams. I guess we also talked about free body diagrams in one of our previous classes. The free body diagrams are a kind of diagrams in which you represent an extended object by a point, and then represent all the forces that act on that point. Extended object, I am an extended object. These tables, they are extended objects. Okay. The cars, the buses, they are extended objects, but you represent them with one single point. What's the rationale between this? Why can we do that? It's because you see, if you have a car, all the car, like the entire body of the car, it moves all together. Okay, the distance, for example, between the front wheels and the rear wheels, it does not change at any time. If the front wheel moves 1 foot forward, so does the rear wheel. That's why you can treat them as point objects. And so I'm gonna go to the fourth one first. So we have this system of masses and pulleys. It is something like this. So we have a mass here, and then we have a mass here, and we are supposed to draw free body diagrams for these masses. This is mass A, this is B. Okay, so what you do, you choose a separate coordinate system for each mass. So if I'm gonna represent this mass B, so this is the representation of mass B, just a point. I have shown it bigger, but you can make it as small as you want. So this is mass B, and then we can see that its weight is in downward direction. So we have the first force W, which is the weight of this mass B in the downward direction. This surface exerts a normal force in the upward direction, and these two masses are connected by a string, and so string exerts a force which is called tension force. It's in the left direction. So this is the free body diagram for this mass B. What about mass A? For mass A, you can choose the coordinate system whatever way you like. I'm gonna choose negative x-axis in this direction, positive x-axis in this direction. Positive y upward, negative y upward. This is entirely different from this one. I deliberately want to do this just to show you the independence that we have in such kind of problems. My system's answer should not depend on this choice. I should always get the right answer, and we will get the right answer. For mass B, so this is mass A, this is mass A, and so I'm gonna represent inclined plane just to make things a little bit clear. this is the weight. Okay, and this weight is not perpendicular to the ground like this one. It makes some angle with the ground. This is the ground line. This is the ground line. So in this case, what I'm going to do, choose my coordinate system such that this is positive x, this is negative x, this is positive y, this is negative y. So you see, I have tilted my coordinate system. Why? Because my system moves on this inclined surface. It moves this way, upward or downward. And so I want to give the physical quantities like acceleration or speed positive or negative values. And that's why I have tilted my coordinate system. And so we have to resolve weight into two components. If this angle is theta, then weight has two components. This component is WA times cosine of angle theta. This component is WA times sine of angle theta. Normal force will be in this direction and tension force exerting in this direction. So this is the free body diagram for second mass. I guess I messed it up in a small space. Okay, so that's how you do it. Let's try the last one, the other one. So we have two masses on top of each other, and that's the surface, the bottom surface, and then we have a mass, this one. This is mass B, and on top of this one we have another mass. This is mass A. And we are supposed to draw free body diagrams for both masses separately. Okay, this is not complicated, like I said, less complicated compared to this one because we have just one plane surface. So one coordinate, choice of one coordinate system will work. And secondly, we have a pulley here, and these both masses are connected by a string which goes over a pulley. Okay, so these masses are connected with a string. We have an external force acting on this one. So this is F external. So first thing first, let's choose x-axis minus x-axis plus y-axis minus y-axis. Can someone come up with an argument why I'm choosing different coordinate system? Positive x towards the right, positive x towards the left in both these cases. Why? I mean, although I had the freedom, I can choose whatever I want. My answer will always turn out to be right. But why did I do that? How can I just look at a diagram and I know which way I'm going to choose my positive x-axis? This inclined plane, this gives you a big hint. You always notice that when you place something on an inclined plane, it just slides down. And so from this diagram, I can immediately see that if this system can slide, it will only slide in this direction. That's why I chose my positive x-axis to be towards left, so that my answers turns out to be positive. If I choose negative x-axis in this direction, then my velocity will be negative if I calculate. My acceleration will be negative if I calculate, and so everything will be negative. Which is equally correct, which just tells you that the object is moving towards the negative axis, but positives are generally good. Okay, so just give me one last moment, I can quickly show you. So for mass A, normal force is in the upward direction, weight is in the downward direction, and tension force is in the left direction. This is for mass A. For mass B, there is also frictional force. No frictional force, so it's fine. For mass B, its weight is in the downward direction. Normal force is in the upward direction, and external force is towards right, and tension is towards left. So these are the free body diagrams for these two masses. If there were frictional force between, let's say, A and B, then you see external force acts on body B. A is attached to B by a string. A would have moved leftward, and so frictional force would have acted this way, and so we would have a frictional force on object A. You can always mark the other forces if they are present. But that's how you generally draw them. Thank you.